Welcome, everyone. Welcome to day 2 of the Flower Summit. As we discussed yesterday, day 1 was all about research. We had a lot of different researchers from all around the world describing how they're using flower to advance state of the art. And so in comparison today, we're going to look at industry. So we're going to have the focus on industry today. We'll have a lot of different companies discussing how they're using flower to put federated learning into deployment, and a lot of complementary discussion about how do you overcome the challenges in doing that. And so just as a brief summary and forward-looking slide here, you can see on the left-hand side of that slide, a brief sort of summary of some of the highlights of yesterday. And so if you weren't able to join us, you missed some pretty exciting things, frankly. In the morning, we announced the Summer of Reproducibility, and how they were going to use that to vastly accelerate the speed at which federated learning is actually progressing scientifically. And we started to give out some of these initial awards. So people like Pedro, folks working in Avion, received the initial awards of 2K for their great effort in doing that. We also had, in addition to all the research talks, we concluded with sort of a social event where we all went to the Tivoli pub for those who were physically present, to sort of really talk about what the future of federated learning and what it means to us. So let me just summarize what's going to happen today now. We've moved through most of the tutorials that you see highlighted at the top there. So we've done the beginner's tutorial, we've done some fantastic iOS-centric tutorials and hands-on tutorials this morning, and there are 2 more tutorials left that we're going to have from the end of the day. One tutorial is going to focus on how you can take centralized industrial workloads and turn them into federated ones in only about 10 minutes. And we're going to have that on a complementary tutorial. We're going to talk about how you do that type of work if you're a researcher as well. Then we're going to have sandwiched in there many different research industry organizations talking about how they've been using flower. Dispersed throughout the day, we're going to have 2 more announcements. So on day 1, we had 2 really important announcements. We announced a fantastic new technology called FedGPT that's going to be launched over the summer and a beta release as a preview. That enables federated learning to join sensitive data, private data, distributed data, and bring those into real-world LLMs. We also announced the reproducibility challenge I mentioned earlier. So today we're going to make 2 more exciting announcements that you're going to hear about. But I think I'm now going to hand over to Daniel, co-creator of Flower, who's going to tell you about an industry-centric roadmap of Flower, where he'll overview both the important sort of key milestones you're going to see in the coming year, and start to tease some of these announcements that you're going to hear in the rest of the day. So over to Daniel.
Thanks for the intro, Nick. And also from my side, a very warm welcome to Flower Industry Day. That's the Flower Industry update. Yesterday, we had quite a few exciting announcements for the research community. Obviously, there's a blurry line, so some of those updates might be interesting to industry folks as well. And today we're going to focus on some important developments that we've started a while ago for industry users in particular. Maybe for a quick introduction and a quick recap of also what we covered yesterday. There's an important movement underway, and it's the open source AI movement. We're seeing that sometimes some innovations, they start maybe in a proprietary fashion, but then pretty quickly the open source community catches up, and in very little time, sometimes just days, the open source solutions just overtake the closed source variants in terms of capabilities and performance and a lot of other metrics. And this is quite an important movement because, especially for industry users, it's not always possible, and actually in most cases it's not possible, to just take your data and send it to some API that runs on someone else's server. Industry users, oftentimes they have the data secured in their data center, and that's a good thing so that they keep control over it. And they need to have access to open source technology that allows them to easily and quickly reproduce with high quality what others have done on their servers. And Flower obviously is a big part of this. And federated learning has been mischaracterized a little bit by some as this niche within machine learning. But as we'll see, it plays quite a pivotal role into bringing machine learning in many new areas that are quite vital to many businesses and many industries, but that are not easily accessible through some model that is running behind some API on someone else's server. And because federated learning is quite a complex beast, there's quite a few moving parts under the hood. We think that our hypothesis is that making it easier and easier to use will accelerate the industry adoption and show more people what is possible. So right now we're in the situation where most of the impressive breakthroughs that we see in AI, they are trained on very little data and on all the data that is public. But compared to all the data that we have in the world, the public data is quite a small subset of this. And there's a lot of data that remains unused because it's not easily accessible by these models. And to once again connect an example to that, imagine we are a data scientist in a multinational company, and maybe we are working in Europe, and we can access all of the data of that organization that sits in Europe. But then maybe if we put that data in the larger context, there's a lot more data all over the world. Maybe the same organization has data in the US and maybe in other regions as well. But because of regulation, it's not easily possible to incorporate all of that data, to move all of that data onto one server and then train your model on it. What we actually want to have is we want to be able to leverage all of this data to train models that are less biased, that incorporate more data into the training process. What can we do? Can we buy more data? That's not easily possible because no one is selling this data. Can we share data? Also not easy, or oftentimes not possible. Can we centralize the data? No, this data has to stay where it is because of regulations like in the medical context, HIPAA, and in other areas, GDPR and similar kinds of things. So maybe we can connect the data. Yes. That's to the audience here, it's probably the obvious solution that we can connect the data, and by connecting the data, we can suddenly start to train those models on all those different distributed data partitions we have, and then train much better models with much less bias than we can do today. And in many situations, because the data that is available in a single region is so small in terms of volume, in many cases, this is really what's necessary to train a model at all, because the small amounts of data, they're not even sufficient. So many organizations, they just don't even start to train a model. And with Flower, we're building this infrastructure to make this easy. What we saw was the cross-silo case. It's called cross-silo federated learning. In the case where different organizations collaborate, or a single organization with different data silos across the globe needs to use federated learning. There's also many situations where data sits on user devices in the medical space. That's quite a good example where we actually can't move the data out of those user devices onto a server. That's called cross-device federated learning. And then Flower really wants to be that infrastructure, or tries to be that infrastructure that works seamlessly and lets you seamlessly train those models no matter where the data is located. And then obviously, in order to do so, you don't want to give up all the tooling that you already have, but you want to use all the tools you know and love, and you want to basically just plug in those existing projects that you have into a kind of system that allows you to incorporate all of those data on different devices and in different data silos. So in order to bring ideas to production in federated learning, it's usually an idea takes 4 stages. It starts with development on a single user's machine, your workstation or your laptop. Then the next stage is to simulate that on a compute cluster where you have more processing capabilities, and where you can run larger scale simulations with simulating a large fleet of edge devices, for example. The next stage is to actually run this on a test fleet of devices to see how the workload would behave on a real set of devices facing the real hardware. And then only the last stage is to deploy this into production, operate it in production on a global scale. Yesterday, we focused on the first two stages. Today, we are going to focus on the last two stages, simulation on devices and then operation in production. But first, maybe a very small community update. The gist is Flower is growing very quickly. And a lot of this growth, actually, especially over the last year, is coming out of industry, and that's quite an interesting trend that we're seeing in the requests here that we're getting. Companies are much more serious about deploying this to production. They're actually putting whole teams to work to build these systems and to deploy these systems, and we're incorporating a lot of this feedback into our development roadmap, as you'll see. We have 2.6K stars on GitHub. Again, 73 contributors, quite a big jump over last year. One interesting thing also for industry users is dependent projects on GitHub. That's quite a small button on the right-hand side if you visit the GitHub repo. But in there, you will find over 800 projects that depend on Flower and that use Flower that build new strategies on top of it, that build interesting models with it. So oftentimes when someone asks, hey, has somebody implemented strategy X, Y, Z? I point them in this direction because there's a lot to discover there. Microsoft has published a tutorial on how to run it on Azure and things like that. Quite big projects from time to time. And then the Flower community still is distributed across the entire globe. When we started doing this and when we started to plot the GitHub stars on the globe, we were actually expecting to see huge concentrations in the usual tech hubs like the Bay Area or London. But we are pleasantly surprised to see that really federated learning is not just used in the major tech hubs, but is really used all over the globe. Now to the feature update. The big thing that we're discussing today is Flower Next. Yesterday, we discussed the driver API, which is part of Flower Next. Today, we're putting that into a slightly larger context. Flower Next is our umbrella term for a lot of the features that we are building right now, the driver API being one of them. And all of those features, they're aiming at making Flower, on the one hand, more flexible for researchers, but then also very importantly, more easier to deploy in production for industry users. And to motivate that or put it in context, if we look at a typical Flower setup as it would be done today with Start Server, usually what we do is we start a server, then we start the client on, for example, in the cross-device setup on some devices. A phone, could be a car, could be even a satellite. Or we have a cross-silo setup where we do the same thing, but then we start the Flower client on those different data partitions in a single data silo, for example, a hospital or a financial institution. Or ideally, the ideal infrastructure would allow us to do all of this and incorporate different devices and different data silos into the same workload. And then here we are as a data scientist using our laptop. We're starting a workload, and that's what the setup looks like. But then our colleague comes along. Our colleague also wants to train a model. So what do we do? With Start Server, actually the most natural thing would be to start a second server and then start a second client on all of these client nodes, and connect them all to that second server and run that training independently on a second server. And then if we wanted to start a second training next to the first one that we started, we would do the same thing over and over again. So the right-hand side starts to look more like a spider web instead of a clear architecture diagram. So it's not really what we want to have. So with Flower Next, we still have this initial situation. We have a server running, we have the clients running, the clients connect to the server, we start our workload, but then our colleague comes along and our colleague can just use the same server. That's the gist of what we're enabling with Flower Next. And that makes it very easy to set up the server once, set up the clients once, keep this federation running, and then start workloads independently, as many as you want to. So if a third colleague comes along and wants to start their workload, they can also start the same server, no additional setup required. Which is, by the way, also especially for industry users, quite a nice thing, because operations engineers, they can keep that setup running, and data scientists can then easily start and stop those workloads, run hyperparameter tunings where they start maybe multiple workloads at the same time, and see which one performs best. And then obviously what we also want to do is we want to secure those workloads with the right permissions, with secure aggregation, with differential privacy, so that no one who uses that infrastructure can run a malicious thing on this infrastructure. So Flower Next, in terms of features, it's there are quite a lot of features that make up this big improvement. Those features, it's a long list, but the good news is actually that a lot of these features have already shipped in Flower. We're building this in a very iterative fashion, and I'm going to give a few updates on some of those upcoming features also. So that's Flower Next. We are building it in the open, commit by commit. Everyone can use it as soon as something becomes available, even in Flower Nightly. And it's going to be stable later this year. Now, in addition to just building in the open, which is what we've always done, everyone could reach us on GitHub, could see the latest commits, could see the latest pull requests even. We are now launching a more systematic effort to connect with a few users, with a few select users, to better understand how the diverse Flower community leverages Flower in their workloads. It's called the Flower Next pilot program. It's open for application. We have limited slots available because we want to select those organizations that really push the boundary of what's possible in Flower. I can only, if you have an interesting workload, if you're about to deploy Flower in production, or if you push the boundaries and you say, hey, what I'm trying to do in Flower is not really easily possible today, but I think it's interesting for the larger community, I can only encourage you to apply. The URL is flower.dev/Flower Next pilot program. Next up is differential privacy. For differential privacy, it's using differential privacy has always been possible. It was always easy to build a client that incorporates a third-party library. We have code examples that show you how to use a Flower client with, for example, Opacus coming out of the PyTorch ecosystem, or use it with TensorFlow privacy and build that in either on the client side or on the server side, or both. Now this year, in addition to those third-party libraries, we launched built-in differential privacy wrappers, which makes this even easier. So you don't have to think about a lot of these details anymore, how to use Opacus, for example, correctly on the client side. But you can just start to wrap your NumPy client with this with the DP wrapper, and then apply DP on the client side. Still, a few hyperparameters still need to be set correctly, and it's just from a research perspective not possible to fully automate this, but we still want to make it as easy as possible for you to just wrap your existing training and then apply DP either on the client side, or there's also 2 other versions to apply it on the server side. That's differential privacy. Next up is secure aggregation. So in this mix of privacy-enhancing technologies, you often hear about federated learning, differential privacy, and secure aggregation. And secure aggregation is something we've worked on for quite a while to get it right, to get it to the level of usability that we want to have for Flower users. And the new version that we're building is fully programmable. But also, if you don't want to customize it, it's basically a plug-and-play solution. So as I said, there's a long history of secure aggregation in Flower. We built the first proof of concept actually in 2021. In 2022, we expanded that proof of concept and introduced different methods. So not just SecAg, but also SecAg Plus and Light SecAg. And now in 2023, we are launching the full version and making it generally available. In addition to SecAg, SecAg Plus, and Light SecAg, we will also have Fast SecAg. But I think the most important announcement is that it will also be easily possible to bring your own secure aggregation algorithm, especially for researchers or for industry users who want to heavily customize what's going on there. This is a very nice way of plugging in your own solution for secure aggregation in a very compatible way without having to change the source code of Flower and build your own version. You can just take the official release and then plug in your own secure aggregation workflow. We had some guiding principles in designing this, and the one guiding principle that we always have is we want to have best-in-class developer experience. We want to have the state-of-the-art approaches that everyone is looking at. We want to have these built in so that you can just use them in a plug-and-play fashion if possible. But it should also be fully customizable, very similar to what we do with strategies, where you have built-in strategies, but you can also bring your own strategy. We wanted to apply the same kind of thinking and principles to secure aggregation. And with that, here's a very simple example of what a secure aggregation workflow could look like. As you can see, it's a simple generator, and you can just specify basically step by step the steps that this protocol is supposed to take, and then plug this into your workload. Very similar to how strategies work. That's fully programmable with secure aggregation. Again, it's plug and play by default, but customizable if required, and it's going to be available later this summer. In addition to that, Flower still has and even expanded best-in-class machine learning framework support. So all the frameworks you know and love. I think this year we have quite a few additions. Fast.ai, XGBoost was requested a lot, especially from industry users. CoreML support on Apple platforms. TabNet is a new one. And we also have Pandas support. And the exciting thing about Pandas is that we now have a federated analytics code example. Federated analytics was always possible, but we got quite a few questions on how to do it. But now with the code example, it's quite easy to look at it and see how this can be built very easily. We also have best-in-class language support. We had Python, C++, and Android for a while. Node.js community supported. And this year we gained a community-supported version of Flutter and a full-blown Swift SDK for iOS platforms. Full SDK and code example. So that's it for the feature update. The important note is there anything that's missing from your perspective? Is there any requirement that you have that you think that should be the first thing they build? Please tell us, absolutely. Yesterday, we also had the Flower Research update, so make sure to check that out. There might be something in there for you as well. But generally, the message is that Flower's roadmap is driven by the community, and all of these initiatives that you see that we're working on are based on community feedback. So if you have something, if you think something is missing, please tell us. That was it for the Flower industry update. I think the biggest announcement of Flower Next pilot program, Flower Next in general, and the combination of federated learning, secure aggregation, and differential privacy will be very easy to use in a short while. I'm happy to take questions. Yes.
I'm curious from a secure aggregation point of view, does that support third-party cryptography protocols and libraries, and how does that actually integrate in a way that's friendly?
Yes, absolutely. So the way that it integrates is on both the server side and the client side, we're making it pluggable. So the communication layer that we build for Flower Next is very generic. So it becomes easy to transport custom messages between client and server. And then obviously the server side implementation, the client side implementation, they need to match up. Our implementation will give you quite a few, all of the most common building blocks that you need to build these kinds of protocols. But then obviously, if you have a very specific library, you can build in those primitives on the client side as well. And then on the server side, create a workflow that leverages these client side components.
My thought when you were about to that later.
Absolutely, absolutely. Sure.
Oh, I had a question from Zoom. I'll go after Catherine.
Yeah.
For different privacy budgeting over time, is there a budget mechanism to adequately track client contribution over time?
I think I would need to look into the implementations that we have. I don't think it is built in yet, but it could be built in a similar fashion to those strategies. Yeah.
The question was about federated analytics and what type of queries we might be able to support in the next 6 months.
Yeah, we have a few plans about federated analytics. So far, it's a pretty custom solution. So it's something where Pandas is used on the client side, and then the local results, along with some other statistics, are being sent to the server side and then aggregated. I think also with the new driver API, this will become even easier. Right now, it's a little bit, in the code example, it's still a little bit cumbersome because the strategy was not really built for federated analytics. With the driver API, this will become more straightforward, and we'll be able to provide a sort of a standardized set of operations that are supported.
Yeah, there's another Zoom question. So it's about the Android SDK, and the person is wondering if it's extendable or not.
So far for Android, we have a big code example. So that's SDK and application sort of mushed into one thing. The next step there will be quite obvious, is to extract the SDK out of that example and publish the SDK as a standalone SDK, similar to how we do it for Android. And then once that's the case, the Android support will work in a very similar fashion to the iOS support and to the Python support that we have.
Okay, well, if there's no more questions, let's thank Daniel for the update.